In this video, we're going to learn about the long division for polynomials. So before we talk about the long division, let's see what we mean by a polynomial. So let's talk about the polynomial first. So polynomial. So when we say poly means many. So that means there are many terms. So polynomial has this form. So let's say px is a polynomial. We normally write this as an, which is a number, times x to the n plus an minus 1, which is another number, x to the n minus 1, like that. And you can see the power decreases, and at the end it's going to be a1, x to the 1, we don't write 1, and then a naught. So, and then we assume that n is a positive integer or 0. If it is 0, you don't see any x terms, so we assume that is a positive integer, positive integer, and then all the ai's are numbers. So ai's are numbers. So n is a positive integer, and then ai's are numbers. They are numbers. Good. So there are a few terms that we need to know. This n, the largest power, this n is what we call the degree of the polynomial. So n is the degree of the polynomial, degree of the polynomial. And then an, the coefficient of the largest term, coefficient of xn, which is called the leading term. So is the leading term, and then a naught, which is the constant term, So these are some terminology that we use. So let's look at a few examples. So examples of polynomials. So let's say px. Px is, let's say, 4x cubed plus 5x squared minus x plus 7. You can see start with 3 and then 2 and then 1, we don't write that, and then 0. So this is a nice polynomial. Let's look at another one, qx. How about this? Negative 7x to the 4th plus x minus 1 over 12. So you can see that this is also a very nice polynomial, x to the 4th, and x3 term, x squared term is missing. That's okay, because that means the coefficient is 0, so you don't see the term. And this is a polynomial. And there are 3 special polynomials also. So for example, let's say sx 3x minus 2. So this is a polynomial. So this is what we call the linear equation, linear function. It's not an equation. Okay, so it's a linear function. And then we have let's say ux, which is equals to, let's say, 8 x squared minus x plus 3. So this is a very special call. This is what we call the quadratic polynomial. This quadratic, why? Is the power is 2. So this is what we call the quadratic. And then we have let's say vx, which is equals to 8x cubed minus x plus 5. So you can see here the power is 3. So we call these kind of ones are cubic. This is a cubic polynomial, cubic polynomial, the third power. And then there are some polynomials which are non-polynomials. For example, let's write few non-polynomials. So what are the non-polynomials? For example, if you say px equal 3 square root x plus 1. This is not a polynomial because you can see in this case n equal the power of x is 1/2. This is not allowed. So this is not a polynomial. And then also let's say qx equal x plus 1 of x. You can see there's a term which has a power. If you bring it to the top, this is n equal -1. This is not a positive integer, so this is not a polynomial. And then also so if you write let's say hx equal sin x or cosine x, ex, those functions are not polynomials. So these are not polynomials. And also there's another very interesting polynomial, the constant polynomial. So we can say kx equal -2, so which is also a nice polynomial. Okay, so kx equal -2, so which is a constant function, which is also a polynomial. It's actually called monomial because there's only one term, but you can put that into the polynomial category. Yeah, so these are kind of polynomials and non-polynomials. Now there are some nice facts about polynomials, so let's talk about that. So there's a knot. So let's say, so if we have a polynomial, so all the graph of polynomials, so graphs of polynomials, graphs of polynomials are continuous functions, are continuous. So that means we can just say polynomial is a continuous function, but if you look at the graph, it's continuous and are differentiable. So these functions are differentiable, are differentiable. That means you can find the derivative. Differentiable means, in other words, what we call smooth. Smooth. So that means no, we can say sharp corners, no sharp corners, or holes, or jumps. So that means if you look at the graph of this, you cannot find places like that. There are no places like that. And if you look at the graph, you cannot find holes like that. So you cannot see something like that. Also, you don't see like jump, like stop here and then jump and go. So this is not exactly right because you cannot have two dots. One has to be open and one has to be closed. So you cannot have something like that. So these are not allowed in polynomials. So this is one of the big facts about polynomials. You cannot see anything like that in polynomials. Okay, and then let's talk about the division. So so before we do the division, let's talk about what mean by the rational function. Rational function. So rational function means if you divide two polynomials, you get one polynomial and divide by another polynomial. So these both are polynomials. So these two are polynomials, any degree. So you get what we call a rational function. So rational function, you can write it like that. And then we have two type of rational functions. So so the types. So the type 1, what we call when the degree of the top function is less than the degree of the bottom function, we call this is a proper fraction. Proper fraction. Proper fraction. And when the degree of the top function in the numerator is greater than or equal the bottom function, either greater than or equal, we call this is a improper fraction. Improper fraction. So if you have improper fraction, what we gonna do? We can divide them just to bring it to the right form. So when you're gonna divide, you can either use the log division or the synthetic division. So we can do this in two different ways, either log division or the synthetic division. So you can look at the video for synthetic division if you don't know about that. Okay, so that's what happened. Now what's going to happen when you divide? You can write in this form. So when you divide the top function by the bottom function, what's going to happen? You get what we call the quotient function. You get one function, that's what we call the quotient function, plus you get the remainder term divided by, you can write it like this. So you can write this one as the remainder part divided by gx. You can write it like that. That's one way to write it. Or you can also write this one as fx equal, you can say the quotient and the divisor, because that's what you're going to buy, divided by, plus the remainder. So there are two ways to write. So you can either write in this form also, or you can write in that form. So there are two ways to write it. The first one is useful especially in calculus and differential equations. So this one is useful in calculus and differential equations. The second one is useful in algebra. So this is useful in algebra. So there are applications of that, and so let's talk about how the long division works now. So we're going to consider several different examples of different various difficulty. So let's start with the first one. So as the first example, we're going to start with this. So let's say, so the problem is divide using the long division. Divide using the long division. Using the long division. So the main argument is there's only one thing that you want to remember. You're going to continue until the degree of the remainder term, is less than the degree of the divisor. So we're going to continue until the degree of the remainder term is less than the degree of the divisor. It will be clear right after we talk about the first example. Good. So let's start. So let's do this example. So example number 1. So let's say divide 3x cubed minus 4x squared plus 5x minus 7 by x minus 1. So if you get that, what we can do, we first check whether we have all the terms in the dividend. So this is what we call the dividend. It's called the dividend. This is what we call the divisor that you divide by. So dividend and the divisor. So what we can do, we can write the dividend first and check whether we have all the terms. In this case, yes, so we have 3, 2, 1, 0. So we have all the terms with all the degrees. So we can write that. So it is 3x cubed minus 4x squared plus 5x minus 7. So we can divide that. So we can write this line. So we can write this dividend on the top because I need some space here. So let's write it. So this is what we call the dividend. Dividend. Divided. Okay. So so we can write it like that. And then what we're gonna do, we're gonna put that factor here. So x minus 1 divisor here. only thing we do is we only compare the first terms. So we could compare the first term, and then we compare the first term, only the largest term, and then we can divide the two. So when you divide the two, you can do this mental calculation. So we divide 3x cube, by only the first term. When you divide, you're going to get 3x squared. So that is the missing term. You only look at the leading term, just the leading term of both, and see what is missing. So you can see missing is 3x squared is missing. Now what we're going to do after we write that, we're going to multiply. We multiply these two, just multiply the two and put it below this. Okay. So and then after you multiply, you're going to put it below. So that means we're going to multiply the first term. When you multiply the first term, you're going to get 3x cubed. So we write just below 3x cubed. It has to match the degree of the top. So they are the same term. And then when you multiply the next term, you're going to get negative 3x squared. So this is negative 3x squared. We write below x squared term. And then the next step is you subtract. Subtract means we again do using this mental calculation, but I'm going to show you what exactly happened here. So what you want to do is you want to subtract 3x cube minus 4x squared with 3x cube minus 3x squared. So you want to subtract them. Instead of subtraction, what we're going to do, we're going to do it a different way. It's still a mental calculation. So you can do like that. You're going to switch the term and add instead. So that's what we do. We switch the term and add. So this is much easier than you can ignore one step. So instead of subtraction, what we're going to do, we switch the term. You see the sign, switch the sign and add. Now what we're going to do, we're going to add them, not subtract, we add them. And when you do that, you see that the first term is 0. The goal is to make the first term 0. And then here you're going to get negative 4, or no, there's no 4 here. So you get negative x squared. That's what you get. That's exactly. So what you're going to do the mental calculation, change the sign and add. Once you do change the sign and add, you're going to get negative x squared. That's what you get. It is very clear. And here it's a 0, so we don't even write that. Okay, so we can ignore that 0 just to make the calculation clear. We don't put the 0 sign there. And then after we do that, then the next step, we're going to move this term down. We're going to move only the next first term down. So just the next one. Okay, so that means in this case it is plus 5x. You move that, and then again, now you compare the whole thing. Look at again, just look at the leading term. So if you look at the leading term of this new expression and the leading term of the divisor, you can see that what is missing is negative x. Negative x is missing. You can also do the same calculation as we did before. We can divide negative x squared with x, just the leading term, and you can see that it is negative x. So that's exactly what goes there. So this is what goes there in the first step. Now this is the next term. So keep doing. So just now you multiply by that only the divisor. When you multiply the divisor, you see that you get negative x times x is negative x squared, and then negative x times negative 1, which is plus x. Now what do you do? You can subtract. Subtract means change the sign and add. So you can see that change the sign and add. First term get cancelled very easily, and then change the sign means negative x. When you add, it becomes 4x. What's the next step? Move this down. So you're going to move this term down. So it is negative 7. Same thing. We're going to see, look at the leading terms. See what is missing. You can see only the 4 is missing. Just the 4 is missing. So that means it is plus 4. Multiply. So you get 4x minus 1, that means minus 4. Subtract, change the sign and add, you get negative 3. So that's it, and this is what we call the remainder. So that's the remainder, and you can see that the degree of that term is smaller than the degree of the divisor, so you stop. So you can see it's a remainder. and then you can see degree of this is, so you can see the remainder, it is the degree of that is less than the degree of the x minus 1, which is degree 1. You can see x minus a degree 1, so it's less than because degree 0. This is a degree 0 term, and the divisor has a degree 1 term, so that means you're going to stop here. So the calculation is going to stop right here because the degree is less than the degree of the divisor. So so that's the answer. Now what we can do, we can write this one in this form. So that means you can write this answer in two different ways. So let's write both forms. So so the one way to write the solution is, I'm going to write that in the next page. So let's say you can write this one as, if you divide 3x cubed minus 4x squared plus 5x minus 7 with x minus 1, you get a quotient as 3x squared minus x plus 4. So that's the quotient. What you get on the top is the quotient, and you get a remainder negative 3. But we write, since we divide, we can write this one as negative 3 over the divisor. We write the divisor here. This is one way. So this is version 1. This is one way to write it. Version 1. You can also multiply by the divisor and write it like this. So the second way to write the same thing is, you can say 3x cubed minus 4x squared plus 5x minus 7 equal the quotient part, that's the quotient, times the divisor, because you multiply by that, minus 3 only. So you can write it like that. So in this case, this is the quotient, this is the divisor, that's the remainder, and this is the dividend. So it's the same term, but you just move the terms around. So this is the version 2. So this is the second version. So this is a version 2. You know, different one are useful in different cases. So but it's good to know both. So let's look at another problem. So let's do this one. So let's say this example. So next example. So divide 3x cubed plus 5x minus 7 by x plus 4. If you look at this one, you can see that there are some terms missing in the dividend. X squared term is missing. So what you want to do is you want to put a 0 for that. So what we're going to do, we can rewrite this one as 3x cubed plus 0x squared plus 5x minus 7. So you don't put a 0 if something is missing, and the rest is exactly the same as before. So we're going to go with x plus 4. Only look at the leading terms, just the leading term. So look at this and that. So you can see the missing term is, if you just divide those two, you're going to get 3x squared. So that's what goes here, 3x squared. And then multiply. So when you multiply, you get 3x cubed. And then when you multiply, you're going to get 4 times 12. You get 12x squared. The next step is subtract. Change the sign and add. So that means you're going to get negative 12x squared when you subtract. And then move this term down, only one at a time. Again, look at what is the missing term. Compare the leading term. When you compare the leading term, you can see that if you divide by x, so what is missing is negative 12x. That's missing. So you multiply by that. so negative 12x squared, and then negative 12, so you get negative 48x. Change the sign and add, so you're gonna get 48 plus 5, that means 53 x, and then move the next term down, negative 7. See what is missing, and you can see 53 is missing. So 53 means it is 53x, and then multiply, so you're going to multiply by 4. When you multiply by 4, you're going to get 212. Subtract, so you're going to get negative 219, and you can see that degree of this is less than the degree of the divisor, so you can stop. Okay, so that's the stop, because the degree is less than the divisor. Okay, so that means we can write the answer for that. So that means if you divide 3x cubed plus 5x minus 7 by x plus 4, you get 3x squared minus 12x plus 53 minus 219 over x plus 4. That's what you get. Yeah, that's one way. The other way is the multiplication, so we can write it like that, or we can write the multiplication. That means it is 3x to the third plus 5x minus 7 equal the quotient, that is 3x squared minus 12x plus 53 times the divisor x plus 4 minus 219. So this is the remainder. So that's the other way to write it, the version 1 and version 2. Okay, so you can see it's very simple. So let's do more. So let's do this one. This may not have good numbers, but that's okay. So so we're gonna do this problem. So let's do a problem that evenly divide. So let's say this one. So next example. So we're gonna do this one. So let's say divide 2x cubed plus 3x squared minus 2x minus 3 by x plus 1. So we can write the term. So it is, you can see everything is there. So it is 2x cubed plus 3x squared minus 2x minus 3 divided by x plus 1. If you compare the leading terms, you can see it is 2x squared is the missing one. So if you multiply by that, you're going to get 2x cubed plus 2x squared, and then subtract. When you subtract, you're going to get x squared, and then we're going to bring the next term down. So it is negative 2x. Compare the leading terms, you can see that x is missing. So when you multiply by that, you get x squared plus x. Subtract. When you subtract, that means change the sign and add, you get negative 3x. Bring the next term down, which is negative 3. Compare the leading terms, negative 3 is missing. Multiply, you get negative 3x, negative 3, subtract, you can see 0. When you subtract, they are equal, that means you get 0. What does that mean? This means that is completely divide. So that means evenly divide. So completely divide. So that's an interesting situation. So that means the quotient is 0. Quotient is 0. I'm sorry, the remainder is 0. So these kind of things are useful. So that means no remainder. And then also useful when factoring. This is very useful. When factoring. So we can discuss this in the factoring polynomial video. This is one of the technique we use. Figure 0, that means it's completely factored. Okay, good. So that means you can write the answer now as so if you had, so that means 2x cubed plus 3x squared minus 2x minus 3 is equals to the quotient, which is 2x squared plus x minus 3 times the divisor and then no remainder. So that's a factor. And then what you can do is you can just think of the factors of the other one, whether you can factor the quadratic. You know how to factor quadratic, so you can find the factors. In this case you can think of 2x and x. And then what do you want to know? We want to see whether you can find numbers for this. It's a negative 3. Negative 3 has only two factors. One is 3 and 1. So you kind of find the numbers so that it's going to match the middle terms. You can see plus 3 and minus 1 works. So that means you can completely factor this one just finding only one factor. So that's how we can use this argument here. Okay, good. So now what we can do is we can think of some cases where it is not really the numbers are not like going well. So for example, so let's do this one. So how about this one? So the next example. So you can see 3x cube minus 4x squared plus 5x minus 7 divided by let's say not just x, like 2x plus 5. So if you do that, you can still do the same thing, but those numbers won't be good, but that's okay. So let's see how it works. So we can start with 3x cube minus 4x squared. You can see there are all the numbers, so that means nothing is missing. Plus x minus 7. If something is missing, you have to add a 0 for that. And then as before, this is 2x plus 5, just the same argument. What we can do, we're gonna divide the leading terms. So if you divide the leading terms, you get 3x cubed divided by 2x. So you're gonna get 3 halves x. That's exactly the missing term here. So that means what you get over there is 3 halves x x squared. Yeah, 3 halves, not x squared. So it's 3 half x squared. That's what you get. And then you're going to multiply by that. If you multiply that, this is going to match. And from the second one is multiply by 5. So that means going to get 15 half x squared. Now what are you going to do? Same thing. Change the sign and add. Once you do the change the sign and add, so what do you get? You have negative 4, negative 15 over 2. So this is easy. You're going to multiply by these two and then add. So you're going to get 8, 15, so 23. So that means it is negative 23 over 2. So what do? You're going to multiply and then add. That's what we do. Multiply and add. first multiply and then add. So you get negative 23 over 2. So that means that's the number you're going to get here. So it is negative 23 over 2x x squared. And then again, bring the next number down. So it is plus 5x. Same argument. What is missing? You can see is 2x. That means you have divided by 2x. So that means what you're going to get is negative 23 over 4 x. That's the missing one. So that means when you multiply, you get negative 23 over 2x squared. And when you multiply by 5, you get negative 115 over 4x. Do the same thing, change the sign and add. So what do you get? You have a 5 and change the sign. So 115 over 4 as before. You're going to multiply these two, that is 20, and add to that. So that means you're going to get 135 over 4. That's what you get. So that means you get 135 over 4x. Again, bring the next number down. So negative 7. Now you can see again what is missing is 135 over 8. That's the next factor goes here. So plus 135 over 8. And then when you multiply, that's going to match 135x over 8. And you can see that here you're going to get 675 over 8. Why? You can see it is negative 7 minus so you can see it's negative 7 minus 675 over 8, and when you simplify, you're going to multiply by 8. You're going to multiply 7 and 8, that's 56, and you're going to add it. This is a multiplication and then add. So you can see you're going to get negative 731 over 8. So that's what you get here. So it is negative 731 over 8. Okay, so that means we have all the numbers. Now we can write the final answer. So that means if you divide 3x cubed minus 4x squared plus 5x minus 7 by 2x plus 5, the quotient is 3 halves x squared minus 23 over 4x plus 135 over 8 minus 731 over 8. So that's the remainder term. So that's the answer you get, but you can still do it. Those numbers are not good, but you can still do it. Okay, so let's see how to kind of avoid some of these numbers. So we're going to do a trick here. So what we're going to do, instead of working with this, we can think of a factor, because we can factor this like this. We can say 2 times x plus 5 half. So that's the one we're going to use to divide, because then you don't have that 2 there, you just have x. So we can use that trick in the next example to see how we can kind of find a workaround for that. So let's do this problem. So the next example, let's say you're going to divide 3x cubed minus 4x squared. Same problem, but we're going to see what's going to happen now. 5x minus 7, let's say, divided by 3x minus 6. It's very similar, but what we're going to do, we're going to think of a factor of that. So what are the factors? So 3 times x minus 2. So instead of dividing by 3x minus 6, we divide by x minus 2 instead. So let's do that. So we have 3x cubed minus 4x squared plus 5x minus 7. All the numbers are there, nothing is missing. So we can divide by x minus 2 instead. So if you have x minus 2, you can see 3x squared is missing. When you multiply, you get 3x cube minus 6x squared. Change the sign and add, so you get 6, you get 2, because it can become positive 6, so you get 2x squared. Move the number down, 5x. Again, think what is missing. You can see 2x is missing. So when you multiply, you get 2x squared minus 4x. Change the sign and add, so you get 9x. Move the number down, so minus 7. You can see 9 is missing, so it is 9x minus 18. Change the sign and add, you get 11. So done. That's what you get. Now what we can do, let's see the trick here. So we can write our problem like this. So what we have, 3x cubed minus 4x squared plus 5x minus 7. So you get the remainder 3x squared plus 2x plus 9 times x minus 2. When you divide, that's what you get, and the remainder is 11. Now the trick is you try to create that term. So how to create that term? You multiply this side by 3, you divide this side by 3. So multiply and divide. So that means in the first expression you divide each term by 3. The second expression you multiply each term by 3. So let's do that. So that means if you divide by 3 you get x squared. Divide by 3 you get 2/3 x, and divide by 3 you get 3. And here you multiply by 3, you get 3x minus 6 plus 11. So that's the workaround, and you can see that's exactly what you want. You want to divide by that, and that's the end. So you avoid dealing with 2/3, because those gonna be very difficult. I mean, it can take time. It's not too difficult, but it can take time. But you can avoid that using this trick. I don't know whether you can find this in books, but this is what I have been using for a long time. I don't think this you can find in any books. Okay, so as the next example, so let's try to see whether we can divide by not just by linear terms, but like quadratic or some higher degree terms. So let's do that. So as the next example, let's do a higher degree, let's divide by a higher degree polynomial. So let's do this one. So divide 2x to the 5th plus x to the 4th minus 6x cubed plus 4x minus 1 by x squared plus x plus 1. So you can see it is a quadratic, it's not linear anymore. So argument is the same. First we're going to check whether anything is missing. You can see the x squared term is missing here. So we're going to make sure that you're going to add that term. So let's write it. So it is 2x to the 5th plus x to the 4th minus 6x cubed plus 0x squared. It's very important. Plus 4x minus 1. And then we write the tabula here. You're going to divide by x squared plus x plus 1. Again, compare only the leading terms. So you can see 2x cubed is missing. So you can multiply by that. So you get 2x to the 5th. That's the first term. You write below the x 5th. And then when you multiply the next term, you get 2x to the 4th. So you write below the x 4th term. And the next one you will get 2x cubed right below x cubed term. It's very important. And then subtract. That means change the sign and add. You're going to see that negative x to the 4th. Here negative 8x cubed. And then the next one is you're going to bring the next term. so which is 0x squared. That's what you get. Same argument. Look at the leading term. You can see that negative x squared is missing. So it is negative x squared multiply as before. So you're going to get negative x to the fourth. When you multiply by the next one, it is negative x cube. The next one is negative x squared. Change the sign and add. So you're going to get negative 7x cube plus x squared. Bring the next term down. So which is 4x. Do the same thing as before. You can see negative 7x is missing. So it is negative 7x. Multiply that. So you're going to get negative 7x squared. Not x squared, x cube. You get x cube. And the next term is negative 7x squared. And then negative 7x. Change the sign and add. So you're going to get 8x squared plus 11x. You can still see that the remainder is still have the degree either equal or more. So that means you will still need to do. So the next one is you can see that just 8 is missing. So we're going to say 8. So when you multiply by 8, so you're going to get 8x squared plus 8x plus 8. When you subtract, you're going to get 3x minus 8. Actually, we need to, before we do that, we forgot to bring the next term down. So here we have that term, so we need to bring it down, so which is negative 1. So that means when you subtract, you're going to get negative 9. So you can see that the degree is degree 0. This is degree 1, so which is less than degree 2 of the divisor. So that means we're going to stop here. So that's the stop one. So that means we can write the solution now. So you can see that in this case we can write this one as 2x to the 5th power plus x to the 4th minus 6x cubed plus 4x minus 1 equal to, if we divide by x squared plus x plus 1, the quotient is 2x cubed minus x squared minus 7x plus 8. And then the remainder is 3x minus 9. So that's what you get when you divide. So so let's do the last problem. So for the last problem, we can do similar one with a term missing. So let's do this one. Say divide the same one, 2x to the 5th plus x to the 4th minus 6x cubed plus 4x minus 1 divided by x squared minus 1. So we did a similar problem using the synthetic division in the other video, and in that what we did was we're gonna split this into x minus 1 and x plus 1 and consider those two zeros separately, 1 and negative 1. But here we just go with the same expression at once. So let's see how it's gonna work. And you can see again the x squared term is missing. So we can write it as before, 2x to the 5th plus x to the 4th minus 6x cubed. Using the 0 here, and then plus 4x minus 1, the division. We're going to go with x squared minus 1. You have to be careful because since the middle term is missing, the terms going to go in different places. So again, only look at the leading terms. So you can see 2x cubed is the missing one. So that means when you multiply by that, you're going to get 2x, because you get 2x to the 5th power. That means you have to write below x 5th power. And when you multiply the next one, you're going to get negative 2x cubed, that means it has to go here. So that's the only difference, and if you want you can add a 0 here, but not necessary. Now change the sign and add. When you change and add, you're gonna get x fourth here because there's no term here, and then when you change and add, you get negative 4x cubed. So that's what you get. And as before, you're gonna move the next term. After you finish, you're gonna move the next term, and then do the same thing. You can see x squared is missing, so we can write x squared here. So we're gonna multiply, so you get x fourth, and then when you multiply, you get negative x squared. So you have to write that the right place. So that's where it go, and change the sign and add. When you do that, you get negative 4x cubed from here, and then this one become x squared. And then move the next term. That's the next term. So it is plus 4x. Look at what is the missing term. You can see negative 4x is missing. So we can write negative 4x. So we're going to multiply by that. So it is negative 4x cubed. And then you're going to multiply. So you're going to get 4x. That means it has to go here. So we can subtract. When you subtract, you get x squared here. And then we're going to move the next term. So that's the next term. When you move it, it is negative 1. And you can see that that's nicely matched with that. So that means the number missing is 1. So that means when you multiply, you get x squared minus 1 is evenly divided. So you get a 0. So that means completely divide. So that means you can write the answer like this because there's no remainder here. So you can see that 2x to the 5th plus x to the 4th minus 6x cubed plus 4x minus 1 equal, when you divide by x squared minus 1, the quotient is 2x cubed plus x squared minus 4x plus 1.